Okay, time to put everything together. Here is section 6. I'm just going to call this using the rational root theorem. We are just going to dive right in, solve problems. We're probably going to get through 2, and then that's it. So here is example 1. We're going to find all the solutions to x to the 5th minus x to the 4th minus 3x cubed plus 3x squared minus 4x plus 4 equals 0. Okay. First of all, this is kind of a scary looking equation. There's a lot of terms here. We haven't seen anything with 6 terms before. How many solutions should we end up with here? Good, 5. We should end up with 5 solutions because of our degree. The degree is 5, that means there's going to be 5 solutions. Now, without knowing that, or well, you knew there was going to be 5 solutions. Without knowing the terminology, you guys actually know this thing called the fundamental theorem of algebra. The fundamental theorem of algebra is the thing that says if the degree is 5, there's 5 solutions. Really, we've been talking about that for, a while now. We just haven't actually called it that. And really, the name doesn't matter, just kind of throwing that in there for fun. Anyway, there's 5 solutions, and I see this equation and I think, oh, there's 6 terms. I don't know what to do with that. So what we're going to do, if we see an equation that doesn't match up with any of the strategies that we've seen so far, what we're going to do is use that rational root theorem from Monday. I'm going to find what are my factors of my constant term here. My constant is 4, so there's really not too many factors. Plus or minus 1, and 4. And 2 and 2 also works. And then my leading coefficient out here, what is my leading coefficient really? 1, yeah. So my only factors of 1 are 1, plus or minus 1. All right, so we're going to come up with our list of possible rational roots. And remember, when we come up with our list, we're going to take our factors of the constant over the factors of our leading coefficient. So I'm going to simplify these as I write them out. We're going to have 1 over 1, plus or minus. 4 over 1 is just 4. And then 2 over 1 is just 2. Okay. Now, going back to what we did on Monday, Monday we listed out our possible rational roots, and then I would ask you if a certain number actually was a root. When we're solving these equations, we kind of have to guess and check a little bit, but these are my only possible rational roots. So if we have a solution that can be written as a fraction, it's one of these 6. I don't have too many possibilities. So we're going to guess one of these 6 numbers. We're going to hope that we guess the right one. What do you want to try first? 1? Let's try 1. Think small. We like 1. 1 is a good one to start off with. So we're going to check if 1 is a root. And then remember, if 1 is a root, that would mean x minus 1 would be a factor. we can check if something is a factor or not by dividing and see if it works out nicely. Can I do synthetic division here? Or do I have to do long division? It's just an x minus 1 here. We can do synthetic division. We only can't do synthetic division if it was like 2x minus 1 or x squared minus 1. Dividing by x minus 1, we can do our synthetic division for. So the opposite of this number is going to go in my box. Oops. I see a minus 1 there, so 1 goes in my box. And then my coefficients go across the top. We have 1x to the 5th, negative 1x to the 4th, negative 3x cubed, 3, negative 4, and 4. And we do our synthetic division. 1 times 1 is 1. We add straight down. 0 times 1 is 0. And then negative 4 times 1 is negative 4. So we end up with this. 0 is our remainder. That's awesome. That means 1 actually is a root. We lucked out. The first number we guessed actually worked. Now, if you had guessed negative 1, for example, first, and negative 1 had a remainder, pick another number to try. Okay? All right. So we got no remainder here. That's good. That means x equals 1 is actually a solution. So I'm going to write x equals 1 and put a box around it. So we know, hey, we have one less solution that we actually have to find. So there's 5 total. We found 1. We have to find the other 4 somehow. Now I think we kind of mentioned this a little bit on Monday. I can use the result of my synthetic division to keep going. So we divided by 1, or we divided by x minus 1. We got this. I can use this to keep going. And here's our remainder. These are our 1s. Here's our x's, x squared, and you don't have to write this out all the time. If I translate this, the result of my division back into x's, I have x to the 4th minus 3x squared minus 4 equals 0. Now let's look at this. X to the 4th. I have an x to the 4th, I have an x squared, and I have a number by itself. That looks familiar. That looks like one of our strategies that we've talked about. This is that fake quadratic strategy. I have a constant, I have an x squared, and an x to the 4th. I can factor this like I normally would, just with one small difference. But the thought process of I want to find what numbers multiply to negative 4 and add to negative 1, that process is the same. So multiplying to negative 4, adding to negative 3, we want a negative 4 and a positive 1. What goes in these spots? Yeah, Julia? Good. X squared. Now this works out really nicely because I can take this piece, or really I can take each of these pieces and find where each piece equals 0. So this first piece, I'm going to add 4 to each side and square root. I get plus or minus 2. And then here I'll subtract 1 from each side and square root. That's plus or minus square root of -1 is I. Now we said we were going to have 5 solutions. Here they are. Here's 2 of them. Here's another 2. And then we had the original x equals 1 that we found out. That was our guess and check solution. Okay, what questions do you guys have? Okay, next example. Let's solve x to the 4th plus x cubed minus 7x squared minus 9x minus 18 equals 0. So right away I look at this equation and I think, oh, there's 5 terms. I don't know how to solve an equation with 5 terms. So let's use that rational root theorem. I want to find my factors of 18 and my factors of my leading coefficient. So factors of 18, we could use 1 and 18, 2 and 9, or 3 and 6. And our leading coefficient is just 1, so my only options there, plus or minus 1. Now we list out our possible rational roots. And that's these guys, all over 1, so that works out pretty nicely. And I'm just going to list these in order. 1 over 1, 2 over 1, 3 over 1, 6, 9, and 18. Few more possibilities here for us. We're going to pick one of them. We're going to try to do our synthetic division and hope that the one that we picked is the right one, that it'll actually work. Now, I'm going to kind of give you a little bit of a spoiler alert right now. If you pick 1, if you try 1, it's not going to work. If you try -1, it's not going to work. If you try 2, -2, none of those are going to work. Kind of a pain in a way, because you could have to guess and check quite a few of these. Like, what if there's only 1 rational root? I guess there would have to be more than 1. What if there's only 2 rational roots and they're 9 and 18? You could have to guess and check all the way up to there. So when we get to our test, what you are going to do is, if you try 1 and 1 doesn't work, like you have your synthetic division down and everything, what you're going to do is you're going to come up to me and say, hey, Mrs. Bishop, I tried 1, here's my synthetic division, it didn't work. And I'll say, all right, you did that correctly. Here it is, x equals 3, that's the actual root. Now keep going with that. Okay. So you won't have to guess and check all of them, because I know it could be time consuming. I don't want to waste your time doing that. As long as I can see that you know what to do, then I'm good. So it turns out in this one, 1, -1, 2, -2, not going to work. 3 does though. So I'm going to tell you x equals 3 works. So if x equals 3 actually is a solution, that means x minus 3 is the factor. So we'll do our synthetic division with a 3 in the box, coefficients across the top. So our coefficients, we have 1, 1, -7, -9, -18. So I bring my 1 down. 1 times 3 is 3. Add down, we get 4. 4 times 3 is 12. Negative 7 plus 12 is 5. And then we keep going. We get 0 as a remainder, which is good because I told you 3 actually was a root. And then we're going to translate this back to x's. 0 is our remainder, here's our 1s, x's, x squared, x cubed. So we have x cubed plus 4x squared plus 5x plus 6. I want to keep trying to solve that. I want to find where that equals 0. And this looks nice, 4 terms. We know a strategy for 4 terms. We can factor this by grouping. It's not actually going to work. Factoring by grouping is not going to work here. And it's up to you if you want to write this part down. I'll just show you here why it doesn't work. X cubed plus 4x squared, the biggest thing I can take out of these 2 terms is x squared. And then I have x plus 4 inside the parentheses. This 5x plus 6, well, the only thing I can take out there is a 1. Why doesn't factoring by grouping work here? Exactly. The things in the parentheses are different. So factoring by grouping doesn't work. Factoring by grouping fails. And that's the only strategy we know when there's 4 terms. So here's what we're going to do. We're going to go back to our list of possible rational roots. And we're going to pick another one. We don't necessarily have to come up with a new list here, because if something is a root of this, it would have been a root of the original. Okay. There are actually a couple we could cross off, because if I look at my list, 9 and 18, they wouldn't be a possibility anymore, because 9 and 18 are both bigger than this guy. Okay. So let's pick another one. Let's try -3 now. And again, I'm kind of giving you guys a little bit of a spoiler here, telling you what it actually is. Okay. Now, if -3 is a solution, that means x plus 3 is a factor. So we'll do our synthetic division, a -3 in the box. When we write out our coefficients, we want to write out the coefficients of this one, not the original. Okay? We're using the coefficients that we got after we did our first synthetic division. So 1, 4, 5, and 6, those are the coefficients we want. Bring the 1 down. And we multiply. 1 times -3 is -3. We add down. There's our synthetic division. We had a remainder 0. That's good. That means -3 actually is a factor. So we're going to translate this now to x's. Here's our remainder, 1s, x's, x squareds. So I have x squared plus x plus 2. I want to find where that equals 0. Now it's kind of a pain, but finally we got to this point where we have x squared. We know a strategy that works for every quadratic function, for every quadratic equation. And really that strategy is the one we need to use here. We would really want to check and see if we could factor this first. Doesn't factor. Why would I not want to complete the square? Good. This guy right here is odd, that coefficient. So I don't want to complete the square. Let's use the quadratic formula. So x equals negative b. B is 1, so negative b is negative 1. Plus or minus the square root of b squared minus 4 times a times c all over 2a. Then we simplify. We have 1 minus 8 underneath the square root, so negative 7 under that square root. And the square root of 7 we can't simplify. We could bring an I out front. So we get negative 1 plus or minus I square root of 7 all over 2.